If you can imagine a world that doesn't have paint in it, how long would your car last? Would aeroplanes fly for very long without falling out the sky? It's a really crucial material. Paints at the moment work quite well. To make them work better and to make them work longer, we need to understand how they work properly from a fundamental scientific perspective, and that's what we don't know at the moment. My work with AkzoNobel is to make that fundamental scientific understanding so that paints can be designed from first principles before they're put out for testing. The work we've done so far has been using all these analytical tools to explore the science behind how the paint works and to create the opportunities to make paints differently. The next stage is to use that information to develop tools that make paints in different ways using different materials which are perhaps more sustainable, which last longer, which create assets which have a much greater lifetime.
The partnership with the University of Manchester started actually well before SusCoRD, and indeed we've had a relationship with the University of Manchester for over 25 years. About 12 years ago we set up a partnership with Manchester because we recognised that corrosion is one of the big challenges that we have to face. We make paint, we develop paint, we understand the practical applications and what's needed to make it perform. What the university brings in their expertise is the ability to characterise, analyse, understand some of the mechanisms. They can do deeper science, and that is an essential part of understanding what's going on. We get fresh insights that helps us to then develop the next generation of paint. SusCoRD contains 4 work packages, and these can be split into sort of 2 main key areas. One is analysis characterization of our coatings. We're looking at the coating and the substrate and the polymer and interfaces. And the second is around digital technology, so machine learning, predictive approaches, but also modeling and simulation with a view to ultimately producing a digital twin of our coating.
There are a number of industries that use these types of paints. Vehicles is one of them, beverage cans, food cans, and assets, what we call infrastructure assets, which can include things like ships, offshore rigs, wind turbines, pipelines, bridges, that sort of thing. In terms of infrastructure, offshore platforms, onshore and offshore wind turbines, in order for them to last longer, they have to be painted well. If you have to repaint them mid-life, that costs a lot of money and kills a lot of profit. If we can make them last the length of the wind turbine, that is a financial benefit.
As AkzoNobel, we recognise our paint has a carbon footprint contribution, and we've set the ambitious target in 2030 of having a 50% reduction in the carbon footprint across the whole value chain. The potential impacts for us as a company are to produce new generation products that perform better, more sustainable, and to do it quicker. You know, the machine learning gives us that angle to accelerate our new product development.
There are 2 aspects of sustainability. The manufacture of the paint needs to be sustainable, but also that its materials need to be sustainable. And that essentially means making it last longer, making it last better. All those things help create value and help create a more sustainable world.